Hi, today we will cover a problem which is called Maximal Square from Leetcode. The description is here. Given a 2D binary matrix fillet with zeros and ones, find the largest square containing only ones and return its area. Example, we have this input, there are ones and zeros, and we have to find the largest square. For example, here is the largest square, this, yeah, so the output is 4. This is the rectangle, here, and that's why it's not valid output. We are looking only a square. We have a square only here, and also every one is also a square with a side 1. Okay. So we can use here the dynamic programming, and also we can choose the same approach like in the maximal rectangle. That this was in another my movie, so you can come back. But there is another solution which is faster in this situation. Okay, and we can explain this. So we have to build the same or maybe one larger. It depends how you can write it. You can write it in the both ways. I prefer to write a little bit larger. Okay, so we have it, and we are building this square. This is on our beginning. First we are checking the if it isn't zero, the size. Then yeah, this is important. Here we are building this matrix, and we go through starting from 1 because we are going through this, and we are checking here the -1. So we are checking we are computing maybe if for example this this point isn't the end of the bottom right edge of a square. For example, if it is here 0, there's nothing, yes, but for example, if it will be here a 1, so maybe here we have to check if this is not the end of the square. Here is the 0, so not this. This isn't the end of the square, but this is the end of the square, which side is 2. This here 2 and here 2, and we have to make it with all. For example, it will be here 1 and 1. We can check that this is the end of the square side 2, and then also we can check that this is the end of side 2, but here and here is also 2, because this is the end of the square, this is the end of the square. If here will be 2, I mean here in this. So So this will be the end of the 3 because we add this. We can okay. So we will fill this matrix, this int integer, this matrix with the end of the square. For example, we are starting here from this because we are starting from 1, so this point, and if the point of -1, so here this, if it is 1, so yes, there is a 1 here, we take a minimum of this, this and this. So minimum of this, minimum of this, and minimum of this. So this is all zeros. The minimum value is 0 when r plus 1, because here is a 1, here is a 1 here. So here we put here 1. And then we check if we have found the max square. If we have found the max square, we remember it, that's all. On the end, we remember only the side, yes? And in the end, we multiply this, the square, making the square of this side, and then we have this area. So, okay, maybe we can go further. Next, first we go through this for the row next in the row, or yeah, in one row the next one. So here is 0, so we do nothing. Here is 1. Okay, so the same. Check this, this, and this. This is all zeros, so here will be 1, 2. And the same. This will be 0. Then check the second. Here will be 1, 0, 1. And here we are checking this point now. So this point here, the minimum is 0 because it's 1, 1 and 0. The minimum is 0, this is the same, plus 1, so this will be 1 also. Moment, okay. Here will be the same situation, the same situation, and the same situation. And here will be first different, because we are checking this this point, and here and here we have 1, and the minimum of these ones are 1. So 1 plus 1 is 2. So R will be 2. Yes. So it's okay. And the same will be here, because the minimum of this 1, 1 and 2, minimum is 1, plus 1 is 2, so here will be 2, and here will be 1, here will be 0, the same, and 1, and here will be the same situation like here. Here will be 2, and sorry, because this is here is 0, so here will be 0, and here will be 1. Yes, exactly. So we can have here 2 and 0, and that's it. And we have found 2 areas with 2's, 1 and here. So the maximum is 4 because we are square this, and that's all. For example, if this will be a 1 here, so here the minimum is 1, and here will be 2, yes. But if this will be 1 here, here will be also 1, and here the minimum will be 1 plus 1 will be 2, so R2, and here the minimum of this will be 2 plus 1 will be 3. So will be something like this, and 3 multiplying by 3 is 9, yes, and the output will be 9 if this will be something like this output. So yes, the complexity will be only with multiplying by height of this matrix, and that's all. And also the space will be the same, height multiplying by width. What's more, there can be a simple improvement here, maybe not simple, but the complexity will be quite the same, but the space you can reduce to only width. We don't need the space to the height. Maybe I can show you just in another example. Yes, here, and we have here almost the same, but we don't have matrix, we have only a vector here. So maybe I can delete it. Okay, and this is something like this here, and we go through this all the same like before. This is one more, but if here, for example, we're starting from 1, the same like previous one, here will be 1, then we take a minimum of. This is virtual, we don't have it. So, for example, if we have here 1, in our previous previous vector, we have also 0, so this was this, and the dp minus 1 index, so here will be 0, and the previous was also 0 because we are starting from this is not this will can be 0 on the beginning, but we are fighting the minimum, so on the beginning doesn't the problem, but we can assume that we can write it 0. Okay, so this will be 0, 0, and this is plus 1, so we can write it 1, yes. Then we go further here, 0, so 0, 1, we are here, so 1, we are looking for the dp minus 1 is 0, dp j in the previous, so the one iteration was 0, and this previous is here. This is the previous 1 minus 1. We are saving it here, and then after we are saved to the previous. So this will be 1, 1, and here also will be 1, or maybe I can write it here also. Yes, this will be 0, 0, and we have end. Then we have here, and so we are taking here, and this is also 0, 0 and 1. The minimum is 0 plus 1 is 1. Okay, we are going further. Here is 0, the same. This 1, here the same, because 0, 0, 1. Here will be 1, so this is 0, 1, 1, 0 plus 1, so it will be 1. Here will be 1, and we are going here, so here will be 1 also. Here will be 0, 1 also. We are here in this section. Okay. Here, now here. So this will be 0, 1, 1 and 0 the same. And we are here, because the previous was here 1. Here also was 1. So, and we have here also 1. So here was 1, 1 and 1, the minimum is 1, plus 1 is 2. So we found it. And then we have here, we have 2, 1, 1, and the minimum 1, and plus 1 is also a 2. So we have found these two things, and we can go further. So here will be 2. Further, so here will be 1. Here will be 0. Here, and here will be 1, 1. So this will be 0, 1, and here previous was 1. Here with 1, so 1, 1, 2 will be 3 here. The minimum is 1, and plus 1 will be 2, and this will be 2, 2, and 3. And you have found it's 3 in this section. So 3 square will be 9. Okay, so this is this small improvement, and we don't need this so much memory. We will need only a vector plus this two values. Okay, so thank you for an attention, and see you next time. Bye.